something changed behind the sun. If you feel that same tension, that pull towards something we're not supposed to see, hit like, subscribe, and comment your thoughts. And if you want others to join us on this journey, share the video, X, Facebook, Reddit, anywhere you can. You're the reason stories like this reach beyond the algorithm. Thank you for being awake. On October 29th, 2025, the interstellar comet 3 Atlas made its closest approach to the Sun and vanished behind the solar glare for 8 days. Before disappearing, it brightened abruptly, shifting to an inexplicable blue hue that defied known cometary behavior. 3 Atlas had been studied for months. Comprising hydrogen, helium, and heavier elements, it likely formed from the remnants of a distant star. Estimated at 5 kilometers wide, it sped through space at over 250,000 kilometers per hour on a hyperbolic path originating far beyond our solar system. However, its behavior turned erratic as it neared the Sun. During those 8 hidden days, something altered 3I Atlas. Upon re-emerging, it continued its journey, deepening the mystery. Scientists at the European Space Agency's station in Malaga, Argentina, watched as the comet reappeared intact, its glowing coma brighter and tinged with an otherworldly blue. The world erupted with speculation. Trends like SAGT 3I Atlas and KAK alien comets spread rapidly. Amateur astronomers shared images, while observatories released data revealing the comet contained elements never seen in such objects, including iridium and platinum, metals typically found deep within planetary cores. The search for answers will span from the Oort cloud to the Sun's corona, from Earth's observatories to laboratories redefining physics and chemistry. We will explore whether 3 Atlas's journey rewrites our understanding of the universe and our place within it. Observation. 3A. Atlas's brightening and color change are unprecedented in cometary science. Its behavior defies conventional explanations. Speculation. Could 3I Atlas be more than natural? Its trajectory, composition, and transformation suggest the possibility of an artificial origin, potentially the first evidence of extraterrestrial intelligence. Part 1. The Ancient Visitor. What if the object hurtling through our solar system is older than the Sun itself? 3I Atlas is more than an interstellar traveler. It is a time capsule from when the universe was less than half its current age. At 10 billion years old, it predates our solar system by over 5 billion years. This object existed before the Sun ignited, before Earth formed, and before anything in our cosmic neighborhood came into being. It has survived countless gravitational encounters and traversed the emptiness of interstellar space, crossing the Milky Way hundreds, if not thousands, of times. The Milky Way is not static. Stars are born, age, and die in supernovae. Galactic arms shift, pulling celestial bodies into new orbits. Yet 3 Atlas persists, a silent witness to cosmic evolution. When this comet formed, the universe was in its youth, with galaxies still coalescing and the first complex structures beginning to emerge. How does something so fragile, a comet, remain intact through such an unfathomable journey? Comets are ephemeral, dirty snowballs held together by weak forces. Time destroys them, radiation erodes them, gravitational perturbations tear them apart. The Oort cloud, a reservoir of comets at the edge of our solar system, contains objects no older than 4.6 billion years, the age of the solar system. Beyond this boundary, the interstellar void is harsh, with cosmic rays, stellar winds, and gravity from passing stars. Yet 3i Atlas is here, ancient, intact, and actively venting gas. Observation. 3i Atlas exhibits a coma, a glowing gaseous envelope and a faint tail, signs of active outgassing. Typical of comets nearing the Sun, this behavior is unusual for an interstellar object. Its composition suggests alteration by processes unknown to local comets. Interpretation. 3i Atlas may have originated in a system vastly different from our own. Its composition suggests formation in a cold, distant region far from its parent star, where temperatures allowed complex molecules to freeze and accumulate. Such conditions, rare in the modern universe, were likely more common in the chaotic, star-forming regions of the early cosmos. Speculation. Could 3i Atlas be more than just a comet? Its longevity and unusual characteristics raise questions about its true nature. Some researchers propose it might be a fragment of a larger body, perhaps a disintegrated exoplanet or a shattered protoplanetary disk. Others suggest it could be a remnant of an ancient stellar collision, flung into interstellar space with enough velocity to escape its parent system. Whatever its origin, 3i Atlas challenges our understanding of comets and the processes that shape them. As it continues its journey, 3i Atlas leaves behind questions and wonder. Its hyperbolic, unbound path will eventually take it back into the interstellar void. But for now, it offers a fleeting glimpse into the deep past, a reminder of the universe's vast and unknowable history. To study this ancient visitor is to peer into the abyss of time itself, where the secrets of the cosmos lie hidden, waiting to be revealed. This alignment has a mere 0.2% chance of happening randomly. Even more remarkably, its journey brought it close to Mars, Venus, and Jupiter, threading a gravitational needle without collisions. Astronomers watched in awe, knowing a slight deviation could have sent it crashing into a planet or out of the solar system. In a seemingly deliberate move, 3i Atlas positioned itself behind the Sun during perihelion, hidden from Earth's telescopes for 20 days. This solar conjunction was a masterclass in celestial mechanics, as if the object exploited our blind spots. The probability of all these alignments, 5 in 100,000 talent, like dealing a royal flush twice in a row. Some might argue this is coincidence. The universe is vast and strange things happen. In 2017, Oumuamua, the first interstellar object observed, followed an inexplicable path. But unlike Oumuamua, 3i Atlas is active. It propels itself with a faint, unexplained thrust of 0.01 millimeters per second squared. No visible exhaust, no cometary tail. It's as if an invisible engine drives it. If 3i Atlas's path is intentional, the implications are staggering. It suggests an advanced civilization capable of interstellar travel and precise navigation of our solar system. It challenges our understanding of our place in the universe and hints we are not alone. Observation. 3a. Atlas's trajectory defies simple explanation. Its alignment with the ecliptic plane, proximity to multiple planets, and disappearance behind the Sun are statistically improbable. Interpretation. While natural explanations cannot be entirely ruled out, the cumulative improbability of these events suggests intelligent design. The absence of a clear propulsion mechanism supports this hypothesis. Speculation. If 3i Atlas is artificial, its creators possess technology far beyond ours. Their intentions remain unclear. Are they observing us, avoiding us, or guiding us toward a greater understanding of the cosmos? Only time and further observation will tell. Part 3. The impossible jet. What if a comet could defy the laws of physics? Between July and August, the Hubble Space Telescope and other observatories witnessed an inexplicable phenomenon. Comet 3 Atlas was venting material directly toward the Sun, not away from it like typical comets. This sunward jet defied known physics, as comets usually develop tails because solar radiation pushes gas and dust away from the Sun. Yet, 3 Atlas formed an anti-tail that persisted for weeks before vanishing in October. The jet stretched over 800,000 kilometers, longer than the Earth-Moon distance, and glowed with unusual intensity. Teams at the European Space Agency and NASA meticulously reviewed their data. Comets' tails, driven by solar wind and radiation pressure, always point away from the Sun. 3i Atlas defied this rule, its jet outshining its nucleus. Spectroscopic analysis revealed exotic compounds, including rare isotopes and molecular structures never before seen in comets, raising questions about its origins and interactions in the outer solar system. How could a comet emit gas toward the Sun? Theories ranged from magnetic interactions with the solar wind to an unknown force. Some suggested a collision with another celestial body, but the jet's alignment with the Sun made this unlikely. Others proposed unusual magnetic materials within the comet, causing unprecedented interactions with the Sun's magnetic field. The anomaly corrected itself as 3 Atlas passed Mars and went behind the Sun. As it neared Mars, its brightness surged and the jet intensified. Then, on October 12th, as it vanished behind the Sun, the jet disappeared. Upon re-emerging in late October, the comet behaved normally, its tail streaming away from the Sun. Observation, interpretation. The correction seemed almost deliberate, as if an external influence had been removed. The answers remain elusive, but the questions grow more urgent. 3i Atlas continues to challenge cometary science as it moves closer to the inner solar system. With more telescopes and spacecraft analyzing it, astronomers hope to uncover whether it is a unique phenomenon or a sign of undiscovered cosmic processes. Until then, the comet's impossible jet remains a cosmic riddle, a reminder of the universe's enduring mysteries. Part 4. The mysterious composition. As astronomers delved deeper into 3i Atlas's gas cloud, they uncovered a narrative far from ordinary. The spectral signature defied conventional classification, glowing with unfamiliar hues. The cloud spanned over 80,000 kilometers, pulsing with an internal rhythm. At its core lay nickel. The comet continuously vented nickel at 4 grams per second, over 126 kilograms daily. This contradicted natural explanations, as comets typically contain less than 1% nickel. 3i Atlas's nickel-to-iron ratio mirrored industrial alloys, not natural stellar chemistry, with a less than 1% probability of occurring naturally. Daily emissions exceeded some terrestrial mines' weekly output. Observation. The sustained nickel emission suggests an internal source or mechanism. Its consistency challenges random collision or contamination theories. Cyclical emission patterns hint at an undeciphered underlying process. Yet, nickel wasn't the sole anomaly. 3 Atlas's water content was a mere 4%, starkly low compared to the typical 70–80%. Despite this, the comet remained active, suggesting an unknown fuel source or internal structure. This mystery captivated astronomers. Speculation. Could nickel drive the comet's activity? Some researchers propose it might fuel a heat-generating process, possibly tied to an advanced technological system within the comet. This theory blurs the line between natural phenomena and intelligent design. Others suggest the nickel could result from an unknown chemical reaction, potentially revolutionizing our understanding of comets. The anomalies continued with traces of rare isotopes like plutonium-244 and curium-247, byproducts of advanced nuclear processes. These, combined with the nickel and low water content, set 3I Atlas apart. Its composition seemed to defy known astrophysics. The isotopes also raise questions about the comet's age, as plutonium-244's 80.8 million year half-life suggests it might be far older than initially thought. Interpretation. 3A Atlas is either an inexplicable natural anomaly or something else entirely, an object challenging our definitions of natural and artificial. Its composition is revolutionary, a puzzle that could redefine planetary science or reveal possibilities beyond our current imagination. If artificial, it would mark the first evidence of extraterrestrial engineering on a cosmic scale, forever altering our place in the universe. Part 5. The Silent Observers. What secrets do the world's most powerful telescopes hold about 3I Atlas? Classified reports and redacted datasets suggest observatories may have deliberately averted their gaze when the enigmatic object came into view. Despite the Punch constellation's high-resolution capabilities, no images from this period were made public. NASA's Mars Reconnaissance Orbiter, equipped with the HiRISE camera, captured images during 3I Atlas's Mars flyby, but never released them. Astrophysicist Avi Loeb's requests for these images were ignored, and NASA cited classification issues. This silence is striking, as HiRISE has produced over 600 terabytes of Martian data since 2006. China's Purple Mountain Observatory, home to the world's largest radio telescope, FAST, tracked 3 Atlas intensively until abruptly stopping post-Mars flyby. Officials attributed this to scheduling conflicts, yet reports of heightened security and military presence at the facility suggest otherwise. Locals noted restricted access roads, hinting at extraordinary observations. The European Space Agency, ESA, also remained silent. On November 5th, their Sentinel-1 satellite captured 3I Atlas, but the radar imaging data was deemed inconclusive and withheld. Leaked memos, however, mentioned anomalies in the object's shape and reflectivity. Sentinel-1's advanced radar system, designed to detect millimeter-scale changes, makes its failure to provide clear data on 3I Atlas suspicious. As data gaps widen, questions mount. What are these observatories hiding? Scientists like MIT's Dr. Sarah Seeger demand transparency. To withhold data about an object like 3I Atlas is not just unscientific, it's irresponsible. The scientific community is divided, with some arguing for caution and others alleging a coordinated cover-up. Observation. The synchronized silence across space agencies suggests a deliberate effort to control information about 3E Atlas. The motive remains uncertain, but the timing of data blackouts, especially around key events like the Mars flyby, is troubling. Interpretation. The lack of high-resolution imagery from NASA and ESA, coupled with their historical willingness to share data on major celestial events, amplifies suspicion. The refusal to disclose even basic telemetry readings hints at suppression of information. Speculation. Some theorists propose that 3 Atlas is not natural, but an artificial construct, possibly extraterrestrial, while purely hypothetical, the refusal to share critical data and reports of unusual activity at observatories, like Purple Mountain fuel speculation that 3 Atlas may be more than just a comet. It could be a technological artifact from beyond our solar system. Part 6. The Blue Light. What if a comet could shine brighter than the sun? 3 Atlas offered a spectacle unlike anything in recorded history. As 3 Atlas neared the sun, it brightened exponentially, its luminosity increasing 100-fold in just a few weeks. Space-based observatories like NASA's Solar Dynamics Observatory, SDO, and the ESA-NASA Solar and Heliospheric Observatory, SOHO, captured its blazing halo stretching 300,000 kilometers, nearly the distance from the Earth to the Moon. This wasn't a typical coma. It was a brilliant, ethereal glow visible even through heavily filtered telescopes in broad daylight. Astronomers watched in real time as the comet's tail stretched and twisted in the solar wind, shimmering like a cosmic aurora. But its color was impossibly blue, defying known physics and challenging the fundamental principles of astrophysics. 3I Atlas emitted light bluer and hotter than the sun's 5,800 Kelvin surface, a contradiction for a comet with a surface temperature hundreds of degrees Kelvin cooler. The comet's light was so intense that it cast faint, eerie shadows on Earth during twilight, a phenomenon not witnessed since the 1882 transit of Venus. Theories abound, but answers remain elusive. Some scientists proposed fluorescent gas molecules excited by solar UV radiation, but the scale of the light was far beyond what such a process could produce. Others suggested reflected light from an unusually bright surface, but this was quickly dismissed, given the comet's ancient weathered composition of organics and silicates. The spectral analysis revealed traces of elements like neon and argon, which are rare in comets but common in artificial lighting on Earth. Observation. The comet's blue light pulsed rhythmically, like a heartbeat, every 17 minutes and 42 seconds. SOHO's large-angle and spectrometric coronagraph, LASCO, recorded these pulsations, which grew stronger as the comet approached perihelion. At its brightest, 3I Atlas briefly outshone Venus, casting faint shadows on Earth that moved in sync with its pulsations. Ground-based observatories detected faint radio bursts coinciding with the pulses, further deepening the mystery. Interpretation. The pulsations could result from the comet's rotation, but the period is too long. Most comets rotate every few hours, not every 17 minutes. Cyclical process within the comet, such as ice sublimation or gas release, could explain the pulsations, but their regularity suggests a controlled mechanism beyond simple explanations. The pulsations also seem to respond to solar flares, brightening and dimming in real time as if the comet were reacting to the sun's activity. Speculation. Could the blue light be artificial, Some researchers propose this, comparing it to Oumuamua, the interstellar object with an unusual trajectory. If artificial, what could its purpose be? A beacon, a signal, or something beyond our understanding? The possibility of an artificial origin raises questions about its creators. Who are they, and why send a glowing object into our solar system? The pulsations, if intentional, could be a form of communication, a pattern waiting to be decoded. The data defies our models. When data doesn't fit models, something unexpected may be occurring. 3i Atlas challenges our assumptions about comets and natural phenomena. As it continues its journey, its secrets remain locked within its icy core, a mystery waiting to be unraveled. Its trajectory will carry it out of the solar system in the coming decades, a silent traveler leaving behind more questions than answers. Part 7. The Hidden Power Source. What if 3 Atlas is more than just a comet? Its rapid brightening, blue light emission, and anomalous behavior suggest it might contain an internal power source. While speculative, this idea aligns with observations and prompts a profound question. Could this object harbor technology functional for billions of years? If so, it would revolutionize our understanding of the cosmos and our place within it, hinting at intelligent life predating humanity. 3i Atlas brightened by a factor of 10,000 in weeks, an unprecedented rate for comets. Its rare blue light emission could result from advanced technology, like a fusion reactor or antimatter engine. Conventional explanations such as outgassing or solar heating fail to account for its behavior, as these processes cause gradual brightening. Among over 4,000 documented comets, none have exhibited such extreme characteristics, making 3 Atlas a true outlier. If 3 Atlas is technological, its perihelion pass could serve as a recharging opportunity. Absorbing solar radiation might explain its brightening and blue light emission. However, its trajectory remained unchanged after perihelion, raising questions about its purpose. The object's surface temperature likely exceeded 1,000 degrees Celsius during this phase, yet it showed no signs of structural failure. Observation. Despite dramatic brightening, 3i Atlas maintained its expected trajectory after perihelion. This suggests that any internal power source was not used for propulsion, but perhaps for maintaining systems, gathering data, or signaling. Its unaltered path implies a design focused on stability and endurance. 3i Atlas could be a probe designed to collect data during its solar system journey. Its power source might operate sensors, transmit information, or process data in real time. Alternatively, it may have malfunctioned long ago, reactivating only as it neared the sun. The sheer scale of the cosmos means such a probe could have traveled for eons, drifting until reawakened by intense solar radiation during perihelion. Speculation. Could 3 Atlas be a derelict relic of an ancient civilization? Its behavior suggests advanced technology, yet it shows no signs of active control. Launched millions or billions of years ago, it may drift on a predetermined path, activating systems only when necessary. If so, it could hold secrets of civilizations that thrived before life began on Earth. The Milky Way alone contains over 100 billion stars, and if even a fraction harbored intelligent life, encountering such relics becomes increasingly plausible. The mysteries of 3 Atlas deepen with each discovery, challenging our understanding of the universe. Whether natural or an ancient artifact, It underscores the vastness of the cosmos and the limits of our knowledge. As telescopes grow more powerful and science advances, Three-Eye Atlas may one day reveal whether it is a messenger from the dawn of time or a cosmic puzzle that will forever defy explanation. Part 8. The Mars Flyby. What happened during Three-Eye Atlas's closest approach to Mars? On October 2nd, the comet passed within 30 million kilometers of Mars, allowing for high-resolution images of its surface and the detection of human-made objects. Yet, Three-Eye Atlas maintained its trajectory, flying by Mars without interaction. Why did it seem indifferent to the red planet and its inhabitants? The timing of the Mars flyby raises suspicion. China's tracking data, which had been closely monitoring the comet's behavior, abruptly stopped after the flyby. Meanwhile, NASA has not released high-resolution images from the Mars Reconnaissance Orbiter, MRO, which could have provided crucial insights. The absence of this data has deepened the mystery surrounding Three-Eye Atlas. Adding to the intrigue, Three-Eye Atlas was obscured by the Sun during perihelion, its closest approach to the Sun. This celestial alignment left astronomers with fragmented observations, as the comet was hidden from Earth-based telescopes for weeks. What happened during this black box period remains unknown. Did solar radiation trigger a transformation in the comet's behavior, or is there another explanation? Congresswoman Anna Paulina Luna and Harvard astrophysicist Avi Loeb have been vocal advocates for transparency, urging agencies to release data. Their efforts reflect the scientific community's demand for answers regarding Three-Eye Atlas. Radio observatories worldwide, including the Allen Telescope Array, Green Bank Telescope, and Parkes Observatory, have monitored Three-Eye Atlas for electromagnetic emissions. So far, no radio transmissions or signs of technology have been detected. The comet continues to behave unusually, with a visible tail indicating ongoing outgassing. The comet's story is far from over, and the data from its Mars encounter may prove critical in unraveling its mysteries. The scientific community watches and waits, hoping for revelations in the months and years to come. Part 9. The WOW Signal Connection. Could the past unlock the secrets of Three-Eye Atlas? In 1977, the Big Ear Radio Telescope in Ohio detected an unusual structured narrowband radio signal from space, lasting 72 seconds. Astronomer Jerry R. Amon, struck by its intensity, famously wrote "Wow" on the printout, naming it the WOW signal. Its frequency, 14 to 20 megahertz, matches the emission line of neutral hydrogen, a proposed universal channel for interstellar communication. For decades, the WOW signal has defied explanation. Despite over 50 follow-up studies, it has never been replicated or traced to a natural source. Here's where it gets intriguing. Three-Eye Atlas originated from a direction aligning with the WOW signal's source within just 9 degrees, an alignment with a 0.6% chance of occurring randomly. The connection deepens. The WOW signal's frequency closely matches the resonant frequency of nickel, an element abundant in Three-Eye Atlas. Nickel's stability and resistance to corrosions make it ideal for advanced engineering. Could the signal have been a beacon guiding this asteroid, or something else, to our solar system? Observation. The WOW signal's origin and Three-Eye Atlas's trajectory align within a 9-degree window. The signal's frequency corresponds to nickel's resonant frequency, an element prominent in the asteroid. Interpretation. This alignment could be coincidental, but its improbability suggests a possible connection. The frequency match hints at deliberate design, though natural explanations cannot be entirely ruled out. Speculation. If the WOW signal was a beacon, 3i Atlas might be its target. Its unusual composition, high nickel content, and anomalous behavior support this hypothesis, though it remains speculative without further evidence. The idea of a guided asteroid raises profound questions about advanced civilizations capable of such feats. The cumulative likelihood of these improbabilities, alignment, timing, composition, and behavior is less than 1 part in 10 quadrillion. Winning the Powerball lottery is 1 in 292 million. You'd need to win it 34 million times in a row to match these odds. Is 3i Atlas an extraordinary coincidence or something more? Was the WOW signal a deliberate transmission, a cosmic breadcrumb leading to this asteroid? If so, who or what sent it? As we stand on the edge of discovery, the mystery of 3i Atlas and the WOW signal reminds us that the cosmos is vast, and our understanding of it is still in its infancy. Perhaps, hidden in the stars, lies an answer waiting to be found. Part 10. The Artificial Hypothesis. What if 3 Atlas is not a natural object? The idea that 3 Atlas could be artificial seems far-fetched, but certain observations give pause. Its hyperbolic trajectory suggests an origin beyond our solar system, rare among comets. Only 2 known objects, 1i Oumuamua in 2017 and 2i Borisov in 2019, have shown similar trajectories, hinting at the rarity of such interstellar visitors. The nickel emission, over 10 times higher than expected, is baffling, as nickel is rarely observed in cometary spectra. The blue light's unusual spectral signature and the sunward jet, a stream ejected toward the sun, contrary to typical comet behavior, further defy conventional explanation. The jet's velocity, measured at over 300 meters per second, exceeds typical outgassing speeds, adding to the mystery. If 3i Atlas were technological, it would mark the most profound discovery in human history, addressing the eternal question: are we alone? The implications stretch beyond philosophy. If interstellar probes exist and traverse our solar system regularly, the galaxy could be teeming with them, ancient artifacts from civilizations long gone or still thriving. Imagine a civilization launching such probes millions of years ago, when humans were barely distinguishable from primates. These silent sentinels might drift through the cosmos, outliving their creators, their surfaces etched with the patina of eons. Distinguishing between natural and artificial origins is daunting, especially with missing data and gaps in the timeline. Yet the search persists. Scientists are analyzing archival data and training telescopes on 3 Atlas to capture every detail. The SETI Institute is listening for non-random signals, sifting through terabytes of data for clues. Researchers have dedicated over 400 hours of telescope time to studying 3i Atlas, scouring its surface for any sign of geometry or structure. Observation. 3i Atlas has a rotational period of approximately 7.3 hours, aligning with both known comets and artificial satellites. Its surface temperature, estimated at 120 Kelvin, is colder than expected for a comet at its distance, raising questions about its composition or internal mechanisms. The object's albedo, its reflectivity, is also peculiar, measuring at 0.03, darker than charcoal and more akin to certain artificial materials designed to absorb light. Interpretation. 3I. Atlas's trajectory, spectral anomalies and thermal properties set it apart from any known comet. While not proof of an artificial origin, these factors demand further investigation. Researchers suggest it could be a defunct probe, its systems dormant after eons of travel, or an active one, gathering data undetectable by our current technology. Its orbit, calculated to have entered the solar system over 50,000 years ago, implies a longevity that defies natural explanations. Speculation. If 3I Atlas is artificial, who are its creators? What kind of civilization could build something for interstellar travel? What was their purpose? And are they still out there, watching as their probe drifts through our solar system? The search for answers may take decades, but the potential payoff is immeasurable. For the first time, humanity might not just be observing the universe, we might be looking back at something observing us. If 3 Atlas is indeed artificial, it would redefine our place in the cosmos, proving we are not alone in the vast expanse of the galaxy. Part 11. The Natural Explanation. What if 3 Atlas is just an unusual comet? Nature is inventive, and the universe is filled with phenomena beyond our imagination. With over 4,000 catalogued comets, these icy bodies show astonishing diversity. Some, like Comet 29P Schwarzmann-Wachmann, have unpredictable outbursts that can brighten the comet by a factor of 100 in mere hours, while Comet 67P Churyumov-Gerasimenko boasts a unique rubber duck shape and active pits that spew jets of dust and gas. 3I Atlas could be another curious entry in this cosmic catalogue, a celestial oddity that challenges our understanding of planetary formation. It might be a fragment of a disrupted planet, torn apart by tidal forces during a close, stellar encounter billions of years ago. Such fragments could have unique compositions, metals, core materials, nickel-iron alloys, unlike typical comets. A cataclysmic event in the early solar system, such as the theorized collision that formed our moon, could have sent these fragments adrift, developing unique characteristics over eons. This scenario could explain 3 Atlas's nickel emission, low water content and structural integrity. Its orbital path, which is unusually elliptical, might also hint at a chaotic origin, as gravitational interactions during the early solar system could have flung such fragments into elongated orbits. What about the blue light? If the fragment contains radioactive isotopes like aluminum-26, uranium or thorium, internal heat could drive unusual chemical reactions. The sunward jet might result from localized venting, where pockets of volatile materials erupt due to internal heating, sending plumes of gas and dust skyward. These jets could include exotic compounds such as cyanogen, CN2 or diatomic carbon, C2, which emit light in the blue spectrum when excited by solar radiation. The rarity of these compounds in typical comets would make 3I Atlas an outlier, but not an impossibility. A natural explanation is plausible, requiring specific but not impossible circumstances. The universe is vast, and rare events happen frequently. Consider the improbable conditions that allowed life to emerge on Earth, a precise blend of chemistry, temperature, and timing that seems almost miraculous. Similarly, 3 Atlas might represent a unique confluence of cosmic forces, a 1 in a billion object that defies easy categorization. Observation. 3i Atlas exhibits unique properties such as its nickel emission spectrum, mysterious blue light, and an orbital eccentricity of 0.97, one of the highest among known comets. Interpretation. These could be attributed to a natural object with an unusual composition and internal processes, like a planetary fragment containing radioactive isotopes. The presence of nickel, a metal rarely detected in comets, suggests a core-like origin, perhaps from a shattered protoplanet. Speculation. If natural, 3e Atlas represents a new class of celestial objects, challenging our understanding of planetary formation. Its composition and behavior could provide clues about the violent early history of the solar system, when planetary collisions were common. If artificial, it suggests past intelligent life in our galactic neighborhood, capable of engineering on a scale far beyond our own. Either scenario has profound implications. A natural 3i Atlas could revolutionize planetary science, offering insights into the early solar system and the processes that shaped our cosmic neighborhood. An artificial origin would redefine our place in the cosmos, hinting at past civilizations that may have thrived and vanished long before humanity's first steps. For now, the mystery persists. 3 Atlas journeys through the solar system, a silent enigma against the backdrop of stars. Its secrets, natural or artificial, await discovery as scientists worldwide focus their telescopes on this peculiar object. The story of 3i Atlas is far from over, and each new observation brings us closer to unraveling its true nature. Part 12. The December observations. As December 19th approaches, 3i Atlas will make its closest pass to Earth in recent history, 269 million kilometers away. This event marks a pivotal moment in a global scientific effort. Major observatories worldwide will unite to study the object, with ground-based telescopes in Chile, Hawaii, and West Virginia working alongside space-based assets like Hubble and the James Webb Space Telescope. Together, they will collect data with unprecedented clarity. Adaptive optics on ground-based telescopes will capture detailed images, while spectroscopic tools will analyze the object's light for unusual materials. Surface features will be mapped with resolutions up to 50 meters per pixel, revealing craters, ridges, or potential artificial structures. Rotation measurements will offer insights into internal composition, with slight wobbles hinting at hollow spaces or anomalies. Thermal imaging will detect any heat sources where subtle temperature variations could suggest buried machinery or geological activity. Observation. 3i Atlas is slightly warmer than expected, averaging 0.5 degrees Celsius above predictions. This excess heat may indicate internal processes or artificial mechanisms. December's data could clarify this or deepen the mystery. If the heat signature fluctuates in ways that defy natural explanations, it might imply intentional control rather than random geological events. Radio telescopes like the VLA in New Mexico and ALMA in Chile will listen for signals. Even faint patterns as weak as 10^4-21 watts per square meter could transform our understanding, while silence might suggest advanced cloaking or a deliberate choice to remain undetected. Interpretation. The absence of detectable signals doesn't rule out artificiality. Advanced civilizations might use communication methods beyond our current detection capabilities, such as quantum entanglement or neutrino-based transmissions. While speculative, these ideas are grounded in known science. Quantum entanglement, for instance, could enable instantaneous communication without electromagnetic leakage, while neutrino transmissions would pass through matter almost undetected. Speculation. 3i Atlas could be an autonomous, self-repairing entity designed to mimic a natural object. It might evade detection by altering behavior when observed. This aligns with principles of advanced AI and nanotechnology, where self-healing materials could repair damage in real time, and AI systems could adapt to observation techniques to avoid suspicion. Scientists will test these theories by looking for inconsistencies such as sudden changes in spin rate or inexplicable surface transformations. Orbital anomalies or thermal fluctuations could hint at propulsion systems or internal activity. Even subtle deviations might reveal the truth. The December observations won't provide definitive answers, but will narrow the possibilities. Each piece of data will either support the natural explanation or challenge it. If 3i Atlas is an artifact, the coming weeks may hint at its true nature, potentially altering humanity's understanding of its place in the universe. The stakes are monumental, not just for science but for our collective perspective on existence. Part 13, the final countdown. The coming months promise unprecedented insights into 3i Atlas, with astronomers worldwide eagerly awaiting data that could transform our understanding of the cosmos. The December observations are more than just significant. They mark a turning point in unraveling the mysteries of this enigmatic object. En route to Jupiter, the JUICE spacecraft will first focus on 3i Atlas during flybys on November 2nd and 25th. Equipped with cutting-edge instruments, JUICE is no ordinary observer. Its high-resolution camera can discern details as small as 2.5 meters from 1,000 kilometers away, while its near-infrared imager penetrates dust and gas to unveil hidden structures. A UV spectrometer analyzes material composition with unmatched precision, and a sub-millimeter instrument studies thermal properties. Additionally, JUICE's sensor for neutral atoms will offer insights into 3i Atlas's interaction with the interstellar medium. However, the process of unraveling 3i Atlas's secrets is far from immediate. Due to the immense distance between JUICE and Earth, data transmission is painstakingly slow. Complete download and analysis of the data will not be finished until February 2026. This delay underscores the methodical nature of scientific discovery, testing the patience and perseverance of researchers. Observation interpretation. The wait will yield invaluable insights. By February 2026, once JUICE's data is fully analyzed and all instruments have reported their findings, a scientific consensus will emerge, not definitive proof, but a shared understanding of what 3i Atlas most likely is. This milestone will represent years of dedication, countless observations and rigorous analysis, showcasing human ingenuity and our relentless pursuit of cosmic knowledge. Long-standing questions about 3i Atlas may finally find answers. Could it be a natural object, a remnant of a disrupted planetary system with unusual compositions and anomalies? Some theories suggest it might be a protoplanet fragment from the early solar system or debris from a cataclysmic collision billions of years ago. Alternatively, could it be artificial? A probe from an advanced civilization exploring the galaxy. The universe has surprised us before, as with Oumuamua, the first interstellar object observed in our solar system. Its unusual shape and trajectory sparked debates about its origins, with some even proposing it could be artificial. While speculative, the idea of Three-Eye Atlas being a probe is not without precedent and would revolutionize our understanding of the cosmos. Once again, the universe reminds us of the vastness of its mysteries. If Three-Eye Atlas is artificial, the implications are profound. It would mean we are not alone, that another civilization exists, perhaps far more advanced than ours. Such a discovery would force us to reconsider our place in the cosmos and confront the question of whether we are the pinnacle of creation or just one of countless intelligent species. Standing on the brink of this monumental discovery, we recall Carl Sagan's words, "Somewhere, something incredible is waiting to be known." Three Atlas could be that something incredible, a beacon of knowledge guiding us into the future. Part 14. The Cosmic Perspective. What does Three-Eye Atlas teach us about the universe? Three-Eye Atlas is just the beginning. The Vera C. Rubin Observatory, launching in 2024, will revolutionize our detection of interstellar objects. With its 8.4-meter telescope and 3.0 gigapixel camera, it will scan the entire visible sky every 3 nights, potentially identifying dozens of interstellar visitors within its first decade. Future missions like the European Space Agency's Comet Interceptor, launching in 2029, could intercept and study these objects up close, offering detailed analysis and imagery. Every interstellar object is a time capsule, providing insights into planetary formation and stellar history. Oumuamua, detected in 2017, challenged our asteroid formation models with its elongated shape and unusual motion. Borisov, discovered in 2019, revealed unique conditions in its natal system through the detection of boron. Its rapid disintegration near the Sun highlighted the fragility of these cosmic wanderers. Observation. Borisov's boron suggested it formed under different conditions than our comets, possibly near a hotter star or in a more energetic system. Its disintegration also showcased the effects of interstellar travel on icy structures. This knowledge has far-reaching implications. Understanding planetary systems helps us identify potentially habitable exoplanets, like those in the TRAPPIST-1 system. Studying cometary compositions, as the Rosetta mission did, traces the origin of Earth's water and organic compounds. Mapping interstellar dynamics with missions like Gaia reveals the galaxy's structure and history. Interpretation. Interstellar objects like Three-Eye Atlas could support the panspermia hypothesis, suggesting life on Earth may have originated from organic compounds delivered by such objects. The discovery of amino acids in meteorites like Murchison already hints at this possibility. Three Atlas refines our understanding of outer solar system dynamics, particularly the Kuiper belt and Oort cloud. Its composition could reveal chemical fingerprints of its parent star system, offering clues about cosmic diversity. Heavy elements like iron or nickel might suggest a birthplace near a supernova remnant. Speculation. Could Three Atlas be a fragment of an exoplanet ejected during a catastrophic event? Its shape, composition, and trajectory could provide insights into the violence of planetary formation. Alternatively, it could be a remnant of a failed star system, a cosmic orphan drifting through the void. In the grand tapestry of the universe, Three-Eye Atlas connects us to the vast patterns beyond our solar system. It reminds us of our place in the cosmic ecosystem, where stars and planets evolve in an endless cycle. As we study these interstellar visitors, we learn about the universe and ourselves, stepping closer to understanding our origins and the potential for life elsewhere in the cosmos. Part 15. The Human Connection. Why does 3 Atlas matter to us? The discovery of 3 Atlas reminds us that the universe still holds secrets, and that discovery is possible with persistence. It highlights our incomplete understanding of the cosmos, which contains around 2 trillion galaxies, each with hundreds of billions of stars. 3 Atlas is a unique anomaly, proof of the universe's ability to surprise and bewilder, and a testament to our role as explorers who build instruments to extend our senses across the cosmos. 3 Atlas offered a tantalizing, confusing glimpse that fueled more questions than answers. These questions drive us to advance our technology, collaborate globally, and push the boundaries of knowledge. Astronomers spend countless hours debating and analyzing, driven by the mystery of 3 Atlas. This collective effort connects us to a larger cosmic community and reminds us of the universe's vast wonders. 3 Atlas has inspired a new wave of interest in astronomy and astrophysics. Universities report increased enrollment in astrophysics courses due to the object's enigmatic nature. Observatories have seen a surge in public engagement, with amateur astronomers contributing valuable data. This collective effort underscores our desire to understand the universe and our place within it. Observation. The night sky has always captivated humanity, from ancient civilizations to modern astronomers. 3 Atlas taps into this timeless fascination, offering a mystery that intrigues both scientists and stargazers. Its interstellar origin adds a layer of awe, as it has traveled through the cosmos for billions of years. Look up at the pre-dawn sky near Venus and find that fuzzy patch of light, a visitor from another star, a 10-billion-year-old mystery. By observing it, you'll participate in one of the greatest scientific investigations of our time, joining a global community of researchers. 3 Atlas challenges our technological and scientific limits. Its unusual trajectory and composition have spurred the development of advanced telescopes and detection methods. The European Space Agency, ESA, and NASA are collaborating on missions to study interstellar objects, representing significant investments in scientific progress. Speculation. What if 3 Atlas is not alone? Future discoveries could reveal more objects like it, providing additional clues about interstellar visitors. As our technology improves, we may enter a new era of cosmic exploration, where the boundaries between stars become less daunting. 3 Atlas is not just about what we know now, but about what we might learn in the future. In classrooms worldwide, 3 Atlas is inspiring the next generation of scientists. Lesson plans incorporate its unique characteristics to teach physics, astronomy, and philosophy. Children are imagining its journey and dreaming of their own discoveries, highlighting the broader significance of 3 Atlas in fostering curiosity and learning. As we gaze at 3 Atlas, we are reminded of our place in the universe. We are tiny, yet capable of reaching for the stars, driven by our curiosity and determination to understand the cosmos. 3 Atlas is a beacon of the human spirit, always seeking, questioning, and reaching for the unknown. Part 16. The final question. Are we alone? This question has driven humanity to explore the cosmos, wondering if among the trillions of planets another civilization might exist. With over 100 billion stars in the Milky Way and at least as many planets, the odds seem to favor life elsewhere. Yet definitive proof eludes us. 3i Atlas doesn't answer this question, but it keeps us asking. Detected in 2017, this interstellar object sped through our solar system at over 196,000 miles per hour, sparking debate about its origins. Natural phenomenon or something more? Its discovery underscored the mysteries of space. The search for extraterrestrial life has evolved since the early days of SETI. Projects like Breakthrough Listen now scan millions of stars using advanced telescopes like the Allen Telescope Array and Meerkat. These tools sift through cosmic noise for patterns or signals hinting at alien life. The Kepler Space Telescope identified over 2,600 exoplanets, including potentially habitable ones. Upcoming missions like the James Webb Space Telescope and Ariel will analyze distant atmospheres for biosignatures. The truth is out there, waiting to be discovered. In 2019, the interstellar comet Borisov confirmed that objects from beyond our solar system frequently pass through. Though natural, Borisov reminded us that the universe is dynamic. Each new detection could reveal life's secrets. So stay curious, stay skeptical, and keep watching the skies. You never know what might be coming next.